Hi everyone, today we are going to study trees in graph theory. A tree is a connected graph without any circuits. So the first condition itself says that tree is a connected graph. That means first of all it is a graph. So basically a tree is nothing but a version of a graph. What kind of a graph? It is a connected graph. So we all know that in a connected graph, every vertex of the graph is connected to every other vertex of the graph through a path. So basically there needs to exist a path between every pair of vertices in a connected graph. So the first condition is that a tree is a connected graph. And then such a connected graph which does not have any circuits. So that means the second condition says that a tree or this kind of a connected graph should not have any self loops and parallel edges, because self loops and parallel edges form circuits. So any connected graph without any circuits is called a tree. If you look at the graph below, this is a tree. You can clearly see that this is a simple graph. That means there are no self loops and no parallel edges in this graph. Hence, there are no circuits in it. Secondly, it is a connected graph because there is a path between every pair of vertices in this graph. So since both the conditions are met, that is, it is a connected graph and this graph does not have circuits, so I can say that this is a tree. Further, you can see trees with 1, 2, 3 and 4 vertices. This is a tree with 1 vertex. This is a tree with 2 vertices. This is a tree with 3 vertices, and these two are trees with 4 vertices. So basically you can see trees with 1, 2, 3 and 4 vertices over here. Now just like as in a graph must have at least one vertex and then you can call it a graph. We have studied that even if there is a single vertex, it can be called a graph, right? So it is not necessary for a graph to have edges, but it is necessary to have at least one vertex. So is the case with a tree. So even if there is a single vertex, you can call it a tree, because a single vertex graph is the simplest graph without any circuits and it is connected in itself. So you can say that a single vertex graph is a tree. So the same condition applies for both a graph and a tree, of course, because tree is a version of a graph only. So in case of tree also you must have at least one vertex, then you can call it a tree. Therefore, now you've seen that what are the conditions for a graph to be called a tree. So therefore you can conclude that a tree has to be a simple graph. That is, it does not have a self loop or parallel edges, because both self loops and parallel edges form circuits. Now let's look at some properties of a tree. There is only one path between every pair of vertices in a tree. Though a tree is a connected graph, but such a connected graph in which there is no more than one path between every pair of vertices. So there will be only one path between every pair of vertices in a tree. This is one condition. So if there is any graph G which has only one path between every pair of vertices, then you can say that that graph G is a tree. Then a tree with n vertices has n minus 1 edges. This is also another property of a tree, that any tree you take, if it has n vertices, then it will have n minus 1 edges for sure. So hence you can say that any connected graph which has n vertices and n minus 1 edges is a tree. Now these two conditions or these two properties we can check in these graphs. Like if I take the example of this particular graph, this is a connected graph, and since it is a tree, therefore you will find that in this connected graph there will not be more than one path between every pair of vertices. Say for example, if you consider these two vertices, there is only one path between these two vertices and there is no other path. Or for example, if you take this and these two vertices, there is only one path between these two vertices. If you start from this vertex, there is only this path available to reach at this vertex, and there is no other path through which you can reach this particular vertex. Or for example, if I take this particular vertex and if I want to reach this particular vertex, then in that case there is only one path, which is this particular path, to reach from here to here. There is no other path available. And like this you can check for all the vertices and you will find that there is no more than one path available between any pair of vertices in this particular graph. Hence you can say it is a tree. Now the second condition says that if there are n vertices in a tree, then it will have for sure n minus 1 edges only. So any such connected graph which has n vertices and n minus 1 edges then can be called a tree. Now let's check if this condition, the second condition, is satisfied here or not. Now now there are in total how many vertices? You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total there are 11 vertices. This red dot is also counted as a vertex over here, right? So since there are 11 vertices, so as per the condition, total number of edges should be n minus 1, which is equal to 10. So you must have 10 edges in this tree. Now let's count the number of edges here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total there are how many edges? There are 10 edges. So both the conditions are satisfied here. And like this you can check for any tree. If it is a tree, you will always find these two conditions to be satisfied.